All right. Hey, Benedetto. We are going live here with our webinar talking about how large language models work and whether they're going to change energy management. And I'm really excited to have this talk with you today. The preparations at least have been fun. So let's see if we can keep it fun during the presentation here as well.
Yes, exciting. Let's do that.
Yeah, great. Let's dive right in. Good. The agenda for today. First, I mean the LLM hype. Is it for real? Should it be hyped, or should it? Aren't they as powerful as we hype them and deem them to be? And then we're going to talk about LLMs, of course, and energy management, both of us working with energy management, both why we're doing it and how. And we'll get to talk a little bit about who these technologies benefit. And then also look into a bit like what is the future of this, and to wrap up and put questions if there are any from the audience. We can take them both ongoing, but also at the very end. Right. I think this is the slide we started with, right? Are they shit, as in are they really bad, or are they the shit, as in really good? Do you mind just giving your perspective of why this slide, Benedetto?
Yeah. So I think in the last 2.5 years since ChatGPT came out, there's been a lot of discussion in the tech world and in general in society around whether LLMs are the future or LLMs are basically useless. And this continues like even now, like just a couple of weeks ago, we had this paper from Apple where they were saying like that basically LLMs can't really reason as everyone claims, or as large AI providers claim they can do, and they are just like parrots that spit out text compared to what they've been fed with. And I think in the end, both these perspectives are right, and it all comes down to what we are using these tools for. So in the end, it's LLMs are a technology, AI is a technology, and we need to just be mindful that depending on the use case where we apply them, we will have some strengths and weaknesses. And as long as we know what are the limitations and what are the things that they can do, I think that they can provide really great help across the spectrum of jobs, and specifically also in energy management.
But Benedetto, it's also not an industry that is kind of short of hype, right? Because I think the promise of these large language models is that basically, human intelligence, once they surpass that, then they can do everything we can do, at least digitally, and build everything that we can, which of course is the if you have very capital intensive industries, you need this hype, because right now they're just burning a lot of energy already. It's a little bit difficult, who to trust, because obviously the creators of these technologies have a certain incentive, and the same you could say with other tongues that are maybe more negative, pessimistic about the implications of these models. Yeah. All right. Let's dive in. Great.
Yeah. So to connect with what you were saying, this is like just a post that we saw on LinkedIn some time ago, and it was some professor complaining that they couldn't use ChatGPT for anything. They had never used it before, and then now they just gave it a task, and it couldn't do at all this task that it was given. And then like it was concluding with what's like basically it's the ultimate fake news generator, it is worth nothing. And then I found it quite funny. Someone commented in the comments something like, yeah, I tried baking a cake in my toaster, and like it couldn't even do a basic cake. And then I tried making an ice cream as well, and it couldn't do that. So this is exactly what we were mentioning before, right? So like LLMs are tools. They can do everything, and they cannot do everything, and they cannot do everything equally well. And so as long as we use them for the tasks that they are good at, we will get out a good result. But as soon as we start using them for things they are not really good at, then we will get, let's say, garbage out. And we always need to keep this in mind, both when using it and also when listening to these claims, no, as you mentioned, like from these top companies that are raising billions of dollars to train these models. They need to keep up the hype. They need to say that we are going towards AGI. Rather than being a little bit more grounded and saying like these are the things that they are good at, and not that they just like replace workers altogether.
Yeah,
I
I
don't know.
agree.
Yeah.
Yeah, well, and just a fun thought, when reading the post to the left, the conclusion, like, then I fired it, is also, it's a little bit dangerous to make conclusions based on a small sample, you could say. If you're trying something the first time and it's bad, and then you are saying, okay, I'm never going to do that for again, then you might be missing out on a lot of things. I'm sure the first dishwashers were terrible, right? And they're in most homes nowadays. And I'm pretty sure that we're going in a direction where all technologies gets better over time. So I'm sure these models will be as well, and they are. There's a lot has happened since just the last 2 years. So just a little side note on this comment here.
Yeah, I agree. And maybe if I can only add to that, like the reason why we are seeing so much pushback is that ChatGPT is the fastest growing technology ever. So it's only because we have that side, like billions queries per day, that we are actually getting this pushback where people saying like, what are you even like doing with this tool if all it can do is like spit out fake news? So I think it's again a matter of finding the right balance, as you say.
Yeah. All right. Okay, so if we see them as new tools, what are they good at then? Let's talk a little bit about that, because I also think that can kind of direct both people that already use it, but also those that maybe not, on directing them to things that they may be really good at, instead of trying to bake cakes in toasters, to use the analogy. Okay, so Benedetto, are they good at writing?
Yeah, so I think this is a good use case. It's one that is quite close to me because I run a blog, a newsletter publication, so I write quite a lot. And of course, like it's reasonable to seek for help from these tools in order to speed up the writing process. And I think it's a good example because it's not easy to answer. And it depends a lot on what you are writing. So when writing, you might have like the creative writing process in which you are trying to create something new. You are trying to create something that is in some way innovative and relatable to the reader, and not just plain and boring, like maybe most texts that these LLMs have been trained on. And then you have another process which you do after that, which is the editing process. So personally, like I think that these models are still quite bad at creative writing, at writing something new and interesting. And so that's why I never use them in the drafting phase. So at the beginning, when I decide, okay, I want to write about this topic, I never start out with a GPT written text, because I'm quite sure that that's going to be boring to read and interesting for no one. On the other hand, where I already have like text that is in quite a good shape. It has my style, it has my tone. I added a few hooks that I think are going to draw the reader in, but I still want to know if there's punctuation error. I'm not a native English speaker, so maybe there's been, I committed some mistakes. And then I can send this to an LLM, and it can provide an editing support that is more advanced than what a typical software that you can use for this would do. So within the same task writing, there's some things that they're really good at and some things that they are not super good at. And so I think that's also why we need to use them a lot and know also how at least in broad terms, how the technology behind them works in order to understand what we should trust them with and what we should not trust them with. But I think you also write a lot during your day, so you probably have an opinion on this as well. What do you think?
Yeah, I use it very little, and that's just because I too lack this original part of the writing process as well. Like the writing process, if you say that you are to write a blog post about something, five things you can do better in whatever field you're in. If you ask for the auto-generated things, and then you fill in the details, then you'll be directed by what is already pre-filled in. So I think there's just you're missing out on a lot of the process. If something only takes 2 minutes, you're like, oh, that's great. It only took a minute to generate all this. But the downside is that it only took a minute to generate all this. So I think it's a lot about the process as well. As we've written here, and I mean, it just highlights this, example that even like a task like writing, there's multiple subtasks in it. So the question is, which of these subtasks can I then get automated? And I think that's also what this is why you cannot just test it on one thing and then conclude anything, right? There will be areas where it's overperforming or performing really, really well as well. And I think that's what we're going to talk about in a second. Some people, at least people in the kind of tech world and those writing code, knows Lovable, which is I think Swedish founded, at least Nordic founded company that aims to build I think what they call the last piece of software, because the whole mission here is that you can have an LLM write your actual code and then build it with just prompts. And I think, Benedetto, this terminology, vibe coding, you've also used a lot lately, right?
Yeah, I think it's become quite popular in the last few months. You might have some critics and some people who support it, but the main idea is that maybe we don't need to know that well the syntax to talk to to a machine anymore, because thanks to these models, we can now more describe in natural language what we would like to do, and they will translate your natural language description into like proper code in a language that needs to be used from the computer side. Which in the end is not that different than like even when we use Python. Python is then basically a translation of lower language, of lower level language that speak more into the language of directly of the machine, which is then like ultimately binary, right? So this is just like a higher abstraction and something that is now making everyone able to create apps and to create code. And I think that we kind of put this example to say that amid all the hype and people that detractors of ChatGPT who are saying that this is not going anywhere, like there are some real results that are difficult to ignore. So in this case, just a couple of weeks ago, the founder of this company was saying how an app built on Lovable in 48 hours made $3 million. And I think this is the representation that this is something that we cannot ignore. And of course, this was, as the post explains, that this was not like two people in a garage. It was like the largest edtech company in Brazil. But maybe in order to create this app before LLMs, it would have taken them months to years, and now they just did it really quickly, and they got the results. So yes, there are things that LLMs are not good at, but also yes, we shouldn't ignore it, and we should use them for the things that they are good at.
But why are they so good at writing code?
Yeah, I think that's because code is a very structured task. Writing code, it's not. It cannot be misinterpreted in some sense. Like it's not a free text as would be, for example, writing. There's only a specific syntaxes that are accepted, and there is a lot of training data available online for that. So that's why these models have been so good at developing code and supporting developers in writing new code. And in the end, the net impact for me is that they are also democratizing what it means to develop an app, and in general whatever whatever requires code development.
Yeah. Okay. Interesting insights. One thing to note here is also that the company that then launched this app, they were already the largest. So like everything in terms of distribution channels and so forth, they probably have set up quite well, right? But it's really interesting to see large companies deploying this, because as you said, it's not just the two people in a garage somewhere. Another example, and I don't have a slide on this because I'm basically wearing it, literally wearing it, is the T-shirt that I have on today. Is bought from a kind of a ChatGPT company. It was a person who decided to launch a company and let ChatGPT 3 back when that came out be the CEO, and he was just the kind of the intern, or doing whatever the AI lords told him, and everything was really processed and set up. And he was, of course, he told about this journey on LinkedIn, and I think they made it like a 30-day period where they were running this company. And he was, of course, also using, the hype, the whole hype around it helped him grow, right? So it's really difficult to take kind of incidents and say, okay, well, this is what it's capable of for doing for everyone, because there's so many other factors that are also playing into the success, like existing distribution channels, or just general hype, or social platforms that are also creating hype and virality that you of course cannot expect to repeat and repeat and repeat. All right, we should really talk about energy management soon, Benedetto. Any last remarks?
Let's do that.
Okay, great. Because obviously we're here because we work with energy management and energy optimization of large building portfolios, and that's what the two of us are working on every single day. So when the models came out, we were of course interested in seeing what we could do to use these models to enhance our product at Ento. I'm just going to do a screen share because that's the best way of really showing what they are capable of today and to play a little bit around with them. So here we're in the Ento app on a kind of a demo account that we have, and this is real data, but it's anonymized. Someone says finally, yes. Let's get to work, right? So the stuff that we would like to show is actually, it was based on the first thing we addressed with these large language models was that sometimes it's a little difficult to understand what to do in our app. So here we're showcasing a site in an electronics store, so a place where you can buy TVs and appliances and whatnot, and we're showing the energy consumption over time. Okay, so our current models are traditional machine learning models that are detecting, for instance, outliers. So here it's a base load issue, so the electricity consumption at night and in the weekends it's going up all of a sudden. So it's saying, okay, well, there's an alert on this side. You guys are spending 80 megawatt hours more than you should, which equates to this amount of money left if you leave it be. So that's basically what you could see, and like if you had time for it, you could find these issues manually. But a lot of our users manage hundreds of buildings or even thousands. So this is kind of the first use case, and then we introduced these large language models where we're saying, okay, well, now you can actually use the AI to generate a suggestion, and I'm just going to do it here. This one was preloaded. We can tweak a little bit back and forth with it. It's a demo account, but it's still working as it does for everybody. So here's saying, okay, so how can I fix a baseload issue? And it's giving a short description of what it is. Okay, it started during this time, and describing the previous levels of the baseload. So again, the energy consumption that's always on at night and weekends, and it represents an increase and so forth. But then interestingly, so what are the likely causes of these things? And with 50% kind of chance, or it's saying that the most likely cause is a HVAC system malfunction or an override. So these central building management systems are a very big source of issues, we can say, across 30,000 buildings that's on Ento. And so it's also actually suggesting some actions here. Verify that the HVAC schedules are in check based compared to the actual needs of this. And then it's saying, okay, well, afterwards, if it's not the HVAC systems, it might be the lighting. And then lastly, there's like unscheduled equipment operations. Any comments, Benedetto, on this?
Yeah, so I think like here what we did was twofold. The first issue that we were facing was customers and our users saying, okay, someone on our team is not technical enough to understand what these graphs that you are showing mean. So we see that there are some lines here. We see that they are going up, but we can't really understand what it means from a physical point of view. And even when we are saying, okay, it is a base load problem, not everyone knows what a base load problem is, or what is the definition of base. And so the first thing that we thought was, okay, let's try to describe these graphs that are so clear for people who have worked for a long time in energy management, or that are into data science and machine learning. Let's try to translate them into something that in natural language that is accessible to everyone. And so that's when we started saying, okay, this is the increase that we've seen, and the increase is mainly happening during the night. And so you start to translate what is just like a mix of lines and colors into a physical idea in your mind of what might be wrong, right, in the building. And then the next step is, okay, since we are now a little bit more aware of what is going on in the building. So there was an increase. The increase is started on this date. It might be starting together with the changes in outdoor temperature. So at the beginning of the heating or of the cooling season, and then we know that it's happening during the night. We can use all of this information to try and nail down the culprit, right? So to try and say, okay, given everything that we know about this issue, what we see from the data, what we know the building is, where the building is located, let's try to say what actually the root cause of this is. And that's what we did with the second part of this suggestion that you're showing, right? So it's like, given everything that we know, let's point the technicians and the energy managers towards what might be the most likely root cause of this issue that we're seeing that was not at all clear when you just look at the graphs.
Yeah. Okay, but then, I think if you are working in energy management, then you know that these are very generic suggestions. So how do we overcome that? Or is there, what do we do?
Yeah, so actually, like the solution is kind of there on the screen. So we say something like, we only have limited sight about this information. Again, this is a demo account. So if you want to have more precise suggestions, you can add a site description. And so you can go to the main page of this site and actually describe in natural language what this site looks like.
And I can both do it down here in the, what we saw before. I can add it. I can just do it here and then say, okay, here's the site description. So we had two. There's a few ways to do this. Of course, you could do it manually, like we're doing right now, because we're literally at a blank slate. And then we can also upload documents. So what we're seeing is that there's a lot of public available data out there about buildings. One thing can be these energy performance certificates, but it can also be industry codes, and Google Maps also have, if you're searching for it, like, it when you're hungry, right? You're on Google Maps and you try to find a restaurant. Well, there's a lot of metadata out there on the buildings that we're already integrating. So there's actually a lot of this information that we can pull from public available data sources, whether they are private or they are part of, government registers. But let's try and put something in and then see how it changes it. What should we put in here?
Yeah, so maybe it's an electronic store, so they might have some TVs or some appliances that they're selling. They also probably have an HVAC system, although that's already expected from any building, and it was what we were suggesting at the beginning. But maybe for the sake of it, we can try to see if. So
I'm just writing in natural language because it is a natural language model, right? So, okay, we have lots of customers visiting during opening hours, 9 to 5, weekdays. I don't know if this is correct, but it's just demo data, right? So, and would like to maintain a good indoor air quality, so it's nice to be here. Great. Updating it. And then the thing is that these suggestions here, they are pre-generated. So they're not pre-generated, but they're made, right? They're based on the descriptions. So if I've now updated the description, I need to rerun and basically ask the model again. Is that correctly understood?
Yeah, exactly. You can refresh it, and then it will delete the previous suggestion and create a new one based on the new information that we have about the building.
Yeah. So right now it's generating. So that means that we're taking some of our data and then using of course, third-party LLM that we integrate with to then come back with a suggestion, right?
Yeah.
Okay, so now it's saying, okay, HVAC system operating off schedule. That's still I think that was the main, root cause before as well. always on displays of IT equipment, that is now something that they know that can happen. And then malfunctioning refrigeration units, that of course could be a thing as well if you have increases in constant consumption and you have refrigeration that is plugged in, right? So it's giving a little bit of more context. I think we have a question too from the audience. I'll just read it out loud and then we can see who is the better to answer it. Are we able to give the LLMs or have them suggest what kind of data that can be relevant to put into the site? So can we actually suggest the what we feed in? Not only to give better insights, but also make sure that you can follow and monitor this site ongoing.
Yeah, I think it's a great question. So the quality of these suggestions, of course, it's better as we give more context about what is inside the building. And now we did a very easy example, but in other cases, we saw, for example, summarizing the energy performance certificate, we could get the capacity of the heating and cooling system, and then that tells you that gives you a number that you can use to say, okay, if this is being left on at night, it could be or it could not be relevant compared to the size of the heating and cooling system that is there, or the size of the water heating system, etc.
I think a really good example of that, and this is demo data, so I don't think we have any heating data on, but a lot of heating systems are water-based, right? And there the flow is, so the heating meter basically consists of a megawatt hour consumption, but also a flow rate. And the flow rate tells you a lot about how the system is, it's how it's circulating water internally in the system. And that information is also used in the model to then give concrete action items like, a high flow and a lot of unused energy in these heating systems is a very good indicator that there's something wrong with the motor valve, especially if it goes from not being a high flow to all of a sudden a high flow, because it indicates that something is stuck or the water flow is constant. So we are using other data sources, you could say, to put into these, and you can put everything in basically. What we do though is, and Benedetto, you can tell more about this, but we're not feeding the models the raw data, right? We're feeding it, our analysis. So we're keeping the data in our clouds. We're not giving away our customers' data. How does that work? Can you tell a little bit about that?
Yeah. So I guess I will get back to the question because I think we didn't fully answer it. But in regards to what you're saying now, I think that in the end, the whole goal of an energy management system is to go from raw data to insight. And then from insight to an action that might be required in order to have a building operating optimally, right? So in this case, we take the raw data and we apply some machine learning. With the machine learning, we are able to detect what are the trends that really need to be taken into account, and then we'll apply the LLMs on top of that result in order to make the results clearly understandable for the user. And so in the end, what we are doing is really shortening this process that goes from raw meter data to taking an action in order to fix an issue. And that requires a lot of processing of the data that we gained expertise on how to do this with years of working on these systems, and so yeah, we are not just giving the raw data to the LLM and saying okay, what can you see here? Because we see that they have not been trained to do that, and so they are not able to understand that and also it will not be secure or acceptable from a privacy point of view. But what we do is like we have our own algorithms. We analyze that raw data. We provide some insights, and then we distill those insights in natural language. And finally, maybe to quickly get back to the question from before, right now the model is not suggesting what extra information should be required, but we are working on a conversational form of analysis in which like we don't just give one root cause suggestion as we have seen, but we actually allow the user to interact with it. And in that case, there would be something like, tell me what data do you need in order to understand if this is the case or not. And then in that case, it might suggest installing some sensors. It might suggest having a walkthrough of the building during the night or whatever is necessary to validate the hypothesis that we have on the issue.
I think a concrete example of that today during our review of these suggestions we do a review currently to see how we can improve them. We had a building with a swimming pool where the gas consumption, it was a building in the UK, where the gas consumption was rising, right? And okay, so what are the leading causes of this? And there, like, and a yes/no question is like, are you using the gas to heat the water? Okay, if that's a yes, then that could be a reason. If that's a no, okay, well then water is out. If you had the water consumption, you could also see, well, is the water consumption in this swimming pool going up? Okay, well, if it has nothing to do with water treatment or water heating, at least not something that has changed, you can ask other questions like, have you changed anything in the temperature? Okay, if that's not a thing, you could look at other technical systems like, is our water treatment working right, or are we actually is there some kind of like a Genvex, like a recirculation of the heating from the water? Is that not working? So I think a lot of these energy management, when you go to that kind of, I need to fix the issues, then some of them can become very complex. And there, this chat interface makes a lot of sense in integrating more data and all of these things. For a lot of applications, it's like electricity at night, okay, check your ventilation system. Water consumption at night, check your toilets, right? But then there's all of these outliers, which is also making it interesting to be us, because it's these more complex systems where more data, specific data, contextual data really helps to understand, well, what is the data we're looking at, like what is this meter even supplying. So I think there's a lot of more context to be given, especially for these difficult cases. With that, we only have 5 minutes left. We need to move forward. Yeah. So Benedetto, I don't know, do you want to say a few? We can basically wrap up what we just said with this, right?
Yeah, I mean, we started with the question like, LLMs, are they the shit or are they shit? And in the end, this is what I think we need to always keep in mind. We have repeated it a few times, but just remember what they do. You just feed them some text, they'll suggest what goes well with the text that they've been given. So they cannot make abstract reasoning for now that has not been already seen in their training data. And this doesn't mean that they're not useful, like we've seen in these cases where we applied it in our Ento app. But we don't expect it to be able to, we give it some of the data of the building or even the time series of the building. We don't expect it to be able to do very complex reasoning and then come up with a root cause for these issues. But what we can use them for is we give them the correct context, and that will make it possible for them to throw out likely explanations based both on the data that we are giving them and on the large amount of training data that they have received when the model was trained.
I saw some. I think there's a little concerning use cases in LLMs, and especially when they're interfering with humans. And I think one of the most severe ones is a lot of very young people use Snapchat, and there you can chat with your new best friend that is on top of your friend list. And if you ask 10-year-olds who got their first phone to ask them questions, I think there's been some cases on like this, and I think that's just a dangerous path, because if you are, there's been multiple people trying, to use ChatGPT as well for basically like psychology or like personal issues, and I think that is probably my biggest kind of warning, is that you should think about, like, you're chatting with a you're chatting with a statistical model, nothing more than that. And adults can understand that to some extent. We can also get tricked into all sorts of things, but we should really think that whatever we put into it and the question we ask might be toned a little bit, like, so we should really think about not using it for something it's really not designed to or capable of, despite the hype. So I think that's my personal experience and thoughts. Okay. Where are we going? I think this is, we're both product interested and also from Ento. We've talked about this Ento hive mind internally, and we have about 30,000 plus buildings. I mean, maybe 35,000. I don't know. This week has been crazy. We've gotten a lot of buildings on. So we're getting a lot of buildings on the platform. We're getting energy projects registered, and our users are using a platform to document energy savings. What can humans still compete going forward, Benedetto? What's your thought?
Yeah, I mean, I think humans can compete with this because we have the expertise, but again, these are tools that can elevate our skills. And if before we would be able to, like, even before Ento, let's say, like, not the LLM part, but in general, like, you would be able to analyze one spreadsheet per morning or something like that in order to look for an issue, because you had to create graphs in Excel and everything. And now you just have a user interface in which you can clearly see all the alerts that you need to look at, right? This will elevate our skills even more, and it will, on the one side, give existing expert energy managers the possibility to go through issues faster and send them directly to technicians with some suggestions that have been pre-filled. And on the other side, it will also get people who are new into energy management back. It will get them up to speed very fast, and this will also be very relevant, I think, from the labor shortage point of view. I think we are lacking, like, a lot of expert people who are hands-on and work in the buildings.
So the labor shortage in terms of, like, managing, for instance, 30,000 buildings will be pretty labor intensive. We've been testing these LLMs also in direct emails, and the feedback has actually been quite good, especially in activating site technicians that aren't necessarily doing energy management every day, but have multiple other jobs. So especially there, that's especially where I've seen this kind of bear fruit early on. Okay, so final remarks here. I'm gonna blast through these, Benedetto. We've used our time. So LLMs can make energy management more accessible and understandable. Like, what is this baseload issue? What are concrete actions I can take? So lifting the non-daily users, you could say. but we can also use them to become very detailed and specific, especially when we give this context. We talked about this chat interference, so going back and forth, giving more information, asking questions back. And as more data is collected, the models improve, LLMs can become a significant asset. And I think the models are already there. It's more about applying them in energy management. We shouldn't trust them blindly. I think that's a really good point to end on, because there is, of course, a collaboration between, how you're using it to write texts. It's like, okay, it's doing the boring job, so I can focus on the fun parts, right? Great. Last but not least, I don't think we'll have time for questions. You can send them afterwards if there is anything. We have hosted a lot of webinars these past few months. I am almost getting tired of doing it. It's also been fun, but in case you want to know more about what we do and how it works, we've hosted a mix of English and Danish webinars. They've actually been mostly Danish now that I see the titles, but they can be seen on YouTube, and they're actually texted as well. So they can also be seen by non-Danish, native Danish speakers. So this was the 6th one and the last one in this series. And planning wise, I can speak. I'm glad that they're done. No, but it's been super fun. And Benedetto, it's been super fun to have you on this last episode. You're of course a huge contributor to a lot of the stuff that we do in Ento, in our regular, advisor product as well. So I'm really glad that you got to join this series as well. So yeah, thanks for being here today, and it was really fun talking to you.
Yeah, thanks, and thanks to everyone who
not at
joined
least good questions. Thanks.